Hi, I am Raju from Smart AI Technologies. Today we will work on topic called handwritten text recognition. First, we will understand what this means. I will give an example. You have a paper where you wrote something. For example, your notebook text. Now you want to convert them into some text and you want to edit something or you want to share it to some people. Then what you can do, you can just scan or capture that image, and from that image you want to give out the text information. This process we call it as an OCR, optical character recognition. Now I will tell you some industrial application, how this gonna help there. First example is of if there is a doctor prescription where he wrote the tablet name and some prescription, how many tablets you should take or like that. He done some prescription. Now using our deep learning model, when you give image to our deep learning model, it should detect what is written on that prescription, and after that it should give user information about that tablet, what is that and how many you should consume at once, what is the benefits are there, what is the drawbacks are there, like side effects are there, about that complete information. This is the one application, and another application is of there are so many departments or companies who are having huge number of documentation with them. Now documentation analysis, in that I will take one particular part as an example. For example, a company is having thousands of application. Now in those thousands of application, they want information, particular information, maybe workers experience how many years in that application. Now what they will do, if they don't have OCR thing, they need to manually check and they need to separate the files. If they don't want to waste that much of time, if they have this handwritten text recognition applied on that, which will detect automatically that particular data, how many years experience, based on that it will automatically classify the images. If you give those pages as an images or scanned data, it will give you the result. It will save a lot more time for the companies. That was the basic. Now we'll start with coding. Before going with coding, I will show you the results, how it works. That will be best. Now you can see here the results. These are some images of the words I gave and it is giving me the output. First one is altered here and comma the and it w up. There are some errors. Why this is happening? Because I trained it for less epochs. I trained it for only 10 epochs. We need to train up to minimum to 50 epochs. Then only we get some good results. These were the results. Now we'll start from the first, how we coded the whole thing. In the data collection part, I imported the dataset. This dataset is from IAM. IAM is having handwritten text as a dataset. There are two actually. One is for words, one is for sentences. We are going with words. I'm importing in this part. In this part, I'm importing the whole dataset. Now, how the dataset exactly look like? The dataset will be having two folders. Yeah, it will be having two folders. One is words folder and another one is words.txt. In the words folder, there will be so many subfolders. Under the subfolder, there will be images within them. And when it comes to word.txt, it will be having all the information about the images. For example, you can see here the last one is the word in that image, and this information is the location path information of that particular image. For that I am displaying word.txt, what is there in that word.txt or like that. After doing that, now I am importing the basic libraries, that is TensorFlow and Keras library, and I am using matplotlib for plotting some graphs or some images. Now after that, how my dot txt file was there, my txt file was having so many lines with hashes. It means I don't want that information, this is the waste information I have. So now what I will do is I need to remove that. That's what I am doing here in this line. First I am checking each line from the txt file. After that I am going for hash which starts with hash. After that, if there is hash, I am not including that line. And also if I include that line, I will check for error, error. Okay, if there is any error in that, I will remove that. Okay, remaining things I will append. My word list will be, now it will be a list of all the lines except errors and hash symbols. I'll just print some of the starting values in that list. It will be helpful for you. You can see. Yeah, first 10 value I am displaying, you can see it. Okay. After that, what I will do, I need to split the data into train, test and validation. For that, how much I need to split it for training, testing and validation. Here I am taking 90% for training, 5% for testing and 5% for validation. Okay, for that I am defining. For the defining, I am taking a split index as a variable. Now for train, from 0 to 95%. Word list nothing but it will be a use number of words. How much is that? Okay, we can print out this length of word list actually. There are 96,456 rows. Now among them I will take 90% of that for my training and 5% for the remaining percent for test samples. After that, for validation I am taking 5% from the test. It means my train will be 90%, test will be 5% and my validation will be 5% now. After doing that, I'm printing the length. Okay, how many samples are there in training and testing? Among 96,456, now 86,810 are for training, 4823 are for testing and 4823 for validation. Now how I need to extract the information now? Get image paths and labels. Okay, in this function, it means how I should get the complete path of image. You can see images are there in words and another subfolder, under another subfolder there is that. You can see, if you see one image, the what is the file name? A0100U. A01, if you see 00U is this folder, and what is there after that is this folder A01. It means there is a relation between the image name and also the folder path. That's what I am doing. Okay, initially I'm taking the whole path. It means the complete word paths. Now I will split line by line. Okay, when I split line by line, I will take first part nothing but A01. Okay, which is there before that hyphen, first hyphen, and which is there after second hyphen, I will separate it. It means A01 slash A01 hyphen 001 slash that complete image name, like that. When I run it, you will be seeing that error. For example, I will print out here. only for train images only. Now we can see here. It means it gave complete path. Data word E001 slash E04 E03 PNG, complete path of an image. In the same way, if you check for the labels thing, what will be? For train labels, you can see it is containing word name, what is there in that particular image, that word, and also some information. Okay, now we will use these two information for the future work, that we call it as preparing the ground truth labels, or I will tell you. Now in our text files, what we have, like from the text files, what we have this information which is having word and some other random information. But what we actually want, we want only the word, we don't want anything. It means in the list, okay, how we will access the data? If I say -1, you can see here, I will go to each label, each line, I will take the last part, that means the only word in, and, the, boy, gastronomy, like that. I will take each word from the last and I will append that, and I will make it as a list that you can see here, which I am displaying. And from that, and I am checking maximum length. It means how many alphabets are there in single word, like maximum alphabets. That's what I am printing. Here in these lines, there I done above, I done for training. The same thing I am doing it for again for test and validation dataset. Now I'm doing two things here. One is char to num. It is using string to lookup library from Keras, which will convert, if you give any data, any string data, it will convert it into some mathematical array. The same thing num to char, it will work in inverse. Like if I say invert true, it will work in reverse manner. That's what I am doing. Why we are doing is, in machine learning and deep learning, the data should be in numerical format itself. You can't give anything in text or string format, because deep learning and machine learning, they work on base of equations or some calculations. When it comes to calculation, data should be in numerical only. If you have variable as in a data for any equations, then you will never get any result. That's why we should always convert whatever the data we have, we should convert it to some array formats. We should convert it to some array and we should give it for training or like that. In this condition, the below thing you can see here, no, what we need to do now is image processing. For the image processing, what we are doing, okay, for the image processing we are following two or three things. Okay, I will tell you what we are actually doing. For example, I say here I am calling prepare dataset function, and what are the inputs I am giving to it? Train image path and train labels. It means the thing are simple here. Train image paths are nothing but input. One is each image path I am giving, each label value I am giving, that is word I am giving. Now using that, what it should give back to me? It should batch and give back the array itself. Array it should give me back. For example, if I give one image and if I tell it like this image is having word say what, okay, then what it should do is it should convert that image into array, it should convert the text into array, it should batch that and give me back. That will be the proper data set which you will use to push to a model for training. Okay, here only a complete dataset preparation will happen. Now what this function prepare underscore dataset will do, okay, that is defined above. What it will do is it will contain three functions now. Okay, first what it will do is it will take each image, it will read the file, and it will decode the image, and it will pre-process the image, that is using function called distortion free resize. And after that what it will do, it will convert it into array. So this is the thing, this is what one function is doing. After that, now text file, what happens to text file? Now the text file, it will take that each label, each word, and it will convert that into array format, okay, and it will give that label as output. Now it will batch them here and it will give back that as a trained DAS. That's what this prepare underscore dataset is doing. Now, okay, now here we are calling one function called distortion free resize, which is pre-processing the whole image. But we want to know what are the pre-processing thing that it is doing. Now for that thing, we need to go to this function. For this, we are initially resizing it for 120 and 30. That's what we defined W and H in the code. So the image will be resized to 120 and 30. After resizing, what I will do, I will pad that on 4 sides. For example, my resized image and the original image, I will take the difference, and how much difference is there, I will pad it on each side. Pad nothing but you can simply take it as, for example, there is a bigger image, there is a smaller image. You will put that smaller image on the bigger image, and whichever the part is remaining, you will color it with some black for that smaller image. Okay, that whole image will be now padded image. After doing the padding, you will transpose it and we will flip the image. Okay, this flipping and transposing, what they will do, they will always improve the accuracy. It's proven. Okay, these processes are used in the pre-processing part of any image classification thing. It will increase the accuracy. Transpose nothing but changing rows and columns, and flipping the image nothing but you can visually see that flip will do like right to left, left to right, image flipping, like mirroring the image or like that. It will give back the image and it will pre-process data set. When it was calling image pre-processing, it means all those processes were done on that each image, and finally that was converted into array, and each labels were converted into array. Now here complete dataset is available. Now complete dataset is available. Now what we are doing is we are displaying images from that batch, from that dataset. Now how it is having the information is, it is having batch of image and its word as a single batch. You can see here sure is an image which is having sure word. All these two are having array format as a one batch, like that. The data is batched now. After doing that, we can push that information to the model, deep learning model. Before going there, we will be building our model. Okay, how will be building model? Like I will display that model information, then you will get. You can see here that model is having convolution 2D. After that, max pool 2D, convolution 2D, and max pool 2D, like this. There are some layers, stack of layers, which are combined and made as a model. Now calculate edit distance is there. Actually, this is used for in handwritten text recognition only, which works better when it displays some error information or say loss information. That's why we use this function. Now there comes a training part. Okay, here I gave epochs as 10. What are these epochs? For that I will give an example. Now assume there is a baby who don't know anything about apple. Now you want to show apple to him and you want to teach him what actually the apple is, like how it looks, how its shape is, how its color is, like that you want to train him. Now what you done, you took one apple and you shown him 10 apples, and you finally you want to test him. You are testing him with some other apples and he is recognizing it. He may not be recognizing it properly, but then what you done is you done again. Okay, you again trained with each apple. Now you are doing second time. Even second time also you didn't learn very well. Now you gonna do it third time, like that. Epochs nothing but the repetitions, how many times you want to train the model. Now I gave here 10, but minimum of 50 needed for getting good results. After training it about 50 or like that, we will be having very less loss. Okay, loss will be below 1 point, or it will be near 0.5, 0.7 or like that. That's actually very good. After doing that, what I will do, I will apply this model over some test data, some test images which are not used in training. That's what you can see here. When I do that, I will get the prediction. My prediction results are like this. For one altered here, you can see here. Okay, this is what we are getting. It means if you train it for 50 epochs, you will get better accuracy. This how projects, the complete code is working. Now what we need to do is we need to use this for further improvements. That is using this for applying it to a complete image. Okay, in that case what we need to do, before going further, we need to work on word segmentations. It means we need to take the whole page and we need to detect where there are words on that image, handwritten words. We need to take them one by one and we need to save them to some location. After that we need to fetch each image and give to this model. It will predict the text. After it will predict the text, we need to take that and make that as a complete sentence. That's how it works. In future videos I will do that. Okay, if you like that video, please subscribe and don't forget to like this video. Thank you.